The time has come for us to officially talk about word problems. So you will see this in math called applications or problem solving. Both just tend to mean word problems. So problem solving equals applications equals, generally speaking, word problems. Now, this is a very long section, so there will be quite a number of videos, but some of the videos are going to have two topics just for the sake of kind of not making it too confusing. So we're going to talk about an introduction to problem solving. So we're going to go right back to that idea of direct translation, and we've dabbled in this a bit in a few other videos, okay? So here's where we're officially going to learn it. So direct translation, we've talked about this before. Direct translation is the process of converting words to math. The goal is to assign a variable to the unknown. Okay, so there's always going to be something unknown. That's what you're going to assign your variable to. Now, the following table includes words and phrases that can be used as a guide to get started. You don't have to memorize this table, but it's useful. Okay, it gives you some hints and some phrases they'll kind of indicate what operation we're looking for. So when we're converting words to math, you're thinking addition, subtraction, multiplication, division, equality. And here are several words that are kind of a guide to this. Okay. So again, take some time, pause the video, preview this table, and then we'll get started. Okay. So example one, it says translate each sentence into an expression. Let the variable x represent the unknown number. Sorry. So we've done stuff similar to this already in previous videos. We're just going to practice it again. Okay. So we're going to look at example one and then example two for this video. So for part A, remember, we're translating this to an expression, and you have to remember expressions, no equals, equations, equals, okay? So when we're going to convert these to expressions, we shouldn't have an equals. We shouldn't have some statement of two things equaling each other, okay? So for part A, it says -9 increased by a number. Well, -9 is easy. But then we want to look at the word increased. Increased makes something bigger. We would think generally addition. So we're going to take -9 and we're going to increase it by some number. We don't know what that number is. That's the unknown. And remember, we're going to let the variable x represent the unknown number. So we would just get -9 plus x. And that's it. Okay. Part B, we have twice the sum of a number in 12. So let's say we have some sum. That sounded crazy. We have some. We have a sum here. We want 3 times or twice that sum, or 4 times that sum, or 5 times that sum, or half the sum. You want to make sure your sum is in parentheses, and then whatever you're doing to that sum is outside the parentheses. So in this case, we want twice an entire sum. So I'm going to take 2 times the sum. And then whatever that sum is, it's going to go inside the parentheses. So here we want the sum of a number. We don't know what that number is, so we're going to call it x and 12. So just be really careful and understand when to use parentheses versus when not to use parentheses. And if you're dealing with, twice a sum, half a sum, 3 times a sum, that sum needs to go in parentheses, and that half, twice, 3 times goes outside the parentheses. Part C, we have 18 minus a number. Now, you do have to be really careful with subtraction. When you have subtraction, order absolutely matters. And here we're told we're taking 18 and then we're going to minus a number from that. So we would take 18 and subtract whatever. In this case, we don't know what that number is. We're going to call it x. Okay, so 18 minus a number is just going to be 18 minus x. Now let's compare that to part D. Part D feels like it's going to be the same, but they're a little bit different. So here we have 18 subtracted from a number. So in this case, we're taking some number, and from that, we're going to subtract 18. So even though these two parts, part C and part D, they feel the same, they're quite different. Order really does matter. So if we take 18 from a number, that means it's going to be the number minus 18 versus 18 minus a number. That's the number subtracted from 18. So be really, really careful with parts C and D. They feel the same, but they're different. All right, let's look at example 2. So example 2 says translate each sentence into an equation. That means there should be some kind of equality going on here. We should have two expressions equal to each other. And again, we're going to let the variable x represent the unknown number. Notice the directions don't tell us to solve. They just want the flat out equation here. Okay, so for part A, it says the product of a number and 2 is 28. Well, is in this case, represents my equal sign. So I'm going to write my equals down. Anything before the word is represents the left-hand side of the equation. Anything after the word is represents the right-hand side of the equation. So before is, we have the product of a number and two. Well, product means multiply. And if we want the product of a number and two, that just means 2 and x. And when you do a product, you don't have to write a multiplication symbol. So when you're doing a product, algebraically speaking, like this, we would just write the 2 and the x side by side, 2 first, x second. So the product of a number and x is 2x, and then that is 28. So that equals 28, and that's it. And again, the directions don't tell us to solve, so we can leave it just like this, 2x equals 28. All right, part B, 11 subtracted from a number is negative 15. So again, we have the word is, that's going to be our equal sign. Prior to the word is, we have 11 subtracted from a number. So be really careful here. Anytime you're dealing with subtraction, order matters. We're taking 11 away from a number. The number needs to go first. We don't know what it is. We're going to call it x. From x, we're going to subtract 11, and then that has to equal negative 15. Okay? So again, subtraction, be extra, extra careful. All right? Part C, we have twice the sum. That means we're taking 2 times an entire sum. So we're going to go ahead and make sure we have a sum there, and we're going to use parentheses so we don't forget. So twice the sum of a number and 1 is the same as. Is the same as indicates our equal sign. And that's going to equal 3 times the difference of a number and 2. So again, we've got 3 times the difference. So there's going to be some kind of a difference. So we've got a sum and we've got a difference. Those both need to be in parentheses. Okay? So twice the sum is going to be 2 times whatever the sum is. And we want the sum of a number and 1. We don't know what the number is. We're going to call it x. And sum means add. So x plus 1. And that is the same as, or is equal to 3 times the difference. So we want 3 times an entire difference of a number and 2. So we're going to use the same number. This said nothing about having multiple variables, so we're going to use x again. And because we're dealing with difference, difference means subtract, we're going to do x minus 2. So 2 times x plus 1 is twice the sum of a number and 1, is the same as, means equals, and then 3 times the difference of a number and 2 is 3 times parentheses x minus 2, okay? Now, part D, it says the difference of 3 times a number and 9. Be careful with this wording here. We're talking about a difference and we've got 3 times something, but in this case, we don't want 3 times the difference. We want the difference of 3 times. So part D, we do not have parentheses, and make sure you know the difference in the wording, okay? So here, the difference of 3 times a number and 9 is equal to, that one's pretty straightforward. That's our equal sign, negative 16. So we have this weird difference. It's going to equal negative 16. So let's look at the difference. We want the difference of 3 times a number. So 3 times a number is just 3x. And from that, we want to subtract 9. That is the difference of 3 times a number minus 9. This would be completely different if I said 3 times the difference of a number and 9. That would be 3 and then parentheses x minus 9. So make sure you understand when you have parentheses versus when you don't, okay? Now we know that 3x minus 9 is 3 times, or is the difference of 3 times a number and 9, and it is equal to negative 16. Okay, so just be really careful when you're converting to expressions or equations. Look for that word that would indicate equality. That tells you have an expression versus an equation. Most of the time from this point on, we're going to be dealing with equations, just so you know. But make sure you can do both, and be careful with subtraction, and then make sure you understand when to have parentheses versus when you don't need those parentheses.